Hello, everyone. My name is Rushikesh Mundkar, and today I'll be presenting on the topic Password Strength Analyzer. It is a system that evaluates how strong or weak a password is and also helps users to protect their online accounts more effectively. So let's begin by understanding the basics of what passwords are and why it's so important for a digital security. A password is the first line of defense in digital security. It protects user identity and data. In today's digital world, passwords are still the most widely used way to authenticate ourselves. However, they are also one of the weakest links because users tend to create simple and easy to remember passwords. Hence, weak passwords are easy targets. Now that we know what passwords are and why we use them, let's see why their strength actually matters. Studies show that over 80% of the data breaches involve weak or reused passwords. Simple passwords like 123456 can be cracked very easily in seconds. Due to weak passwords, people have to face financial, privacy, and reputation loss. This is why strength and uniqueness of password is crucial. Now let's explore the most common attacks faced by the user due to weak password. Hackers break into system through various methods like brute force, which tries every single possible combination, to dictionary attack, which uses common words or passwords, to phishing, which tricks users into revealing passwords, and credential stuffing, which reuses stolen passwords. To prevent us from these attacks, we need better tools. That's where the password strength analyzer comes in. A password strength analyzer is a tool designed to evaluate the strength of the password. It checks parameters like length, complexity, unpredictability, and randomness. It also gives users a score or rating from very weak to very strong. It also helps users to improve their passwords by giving them a real-time feedback. Now let's break down of how a password strength analyzer works. A password strength analyzer first checks parameters like length, variety, absence of patterns, and measure of randomness, which is entropy. So the higher the entropy, the stronger will be our password. A password strength analyzer will also look for words which are not in common dictionary. Now let's look at the main components that make up a password strength analyzer. So a password strength analyzer includes an input field that the user will enter his or her password, a core algorithm which will check the complexity of the password, a scoring system which will assign rating to users from very weak to very strong, and finally a feedback display which will show results and also help users to improve his or her password. Now, when these components work, this is how our code will first, we'll take the password as input from the user. Then we will check the conditions required for a password to be strong. Then we'll finally count score based on these conditions. And finally, we'll display the strength of the password. So the conditions used are the password length should be greater than equal to 8. It should also contain uppercase letters. Should also contain lowercase letters. It should contain digits from 0 to 9. And also special characters like category, hashtag, dollar sign, etc. All these conditions are necessary for a password to be considered as strong. So now that we have completed the introduction part, let's jump into the implementation. I've implemented the C++ language using this code as my IDE. The code demonstrates modular programming. Modular programming is basically programming done by breaking the code into separate modules or functions. The code also demonstrates conditional checks like if else. The code evaluates password strength based on the conditions discussed earlier, like password length should be greater than equal to 8. It should contain uppercase letter. It should contain lowercase letter. It should contain digit. It should contain special character. The code also calculates the score and classifies it as very weak, moderate, strong, and very strong. It also gives the user feedback and suggestions to improve the password strength. Let's now look at the structure of the code. So I've divided the code into separate functions where each function checks a specific aspect, such as is uppercase will check whether the code has a uppercase letters. Is lowercase will check whether the password has lowercase letters. Is digit will check whether digits like 0 to 9 are present uh, or not. Has special char will check for special characters. Check strength will check the overall strength of the password. Suggestions will finally print suggestions to the user to improve his or her password. Finally, the main function integrates all these sub-functions and gives us the overall strength of the password. So we first start by including the libraries. First, we include IOStream library, which lets us use stdcin and stdcout for input and output. Then we include string library to for handling text efficiently. Uh, we also use using namespace std so that we don't have to use this std repeatedly. Now let's look at the subfunction which we'll be using. First, we will be using bool is uppercase to check whether a character is uppercase using ASCII values. Because we have used the bool data type, so it will either return true value or false value. So, for it to be returning true value, the character has to lie between capital A and capital Z. Similarly, for lowercase letter, we use bool is lowercase. This function checks for the lowercase letters. Again, because we are using bool data type, it will return true value if the character lies between small a and small a. And we also check for digits from 0 to 9. So we use the function bool is digit. This checks the character is a number using its ASCII range. Again, it will also return true value if the character entered by the user lies between 0 to 9. Now let's see the function to check the special characters. So we'll be using bool is special to check if there are a special character present in the password or not. So we do so by using ASCII values. So here are some of the ASCII values which denote a special character. So the range is from 33 to 47, 58 to 64, 91 to 96, and 123 to 126. So basically what this function does is it checks whether the special character assigned to a specific ASCII value is present in the password or not. Basically, if the user types any character, so this function will check if the ASCII value assigned to that specific character lies in this range or not. If it does not lie, then it will return a false value. If it is present in this range, it will return a true value. For example, if the user types accurate value, so the ASCII value of the accurate value is 64. As you know, 64 is in this range, so it will return a true value. But for example, the user types 3, so the ASCII value of 3 is 51. As we can see, 51 is not in this range, so it will return a false value. Now let's move on to the main function where we'll be taking the password as input from the user and we will also be defining some new variables. First, main function, it is the starting point of program. This is where the execution of the code begins. So the compiler starts compiling the code from the main function. So in the beginning, we'll be asking the user to enter his or her password, which is to be checked. We do so by defining a variable password of data type string. We'll also be defining variables as upper, as lower, as digit, as special of bool data type. so that we can perform the sub-function which we have declared earlier. So now we'll be defining a new function, check password strength, to basically give us a score and rating based on the strength of our password. So to use this function, first we have to use the variables that we declared in the main function, such as password, has upper, has lower, has split, and has special. Now to use these variables, we have two methods. First is by pass by value, and second is by pass by reference. So the difference is that when we use pass by value, and a copy is made and it is sent to the subfunction. And when we use pass by reference, the original value is sent and it is modified. And that is exactly what we need. Hence, we'll be adding an and symbol uh, after the data type and before the variable name to basically pass by reference. Uh, Also, we'll be defining a new variable length to basically calculate the length of the password. Here, this function int length equal to password dot length semicolon will be used to calculate the length of the password. Also, these variables has upper, has lower, has digit, and has special will first set to false. Basically, in bool data type, false means zero. Now we'll be using for loop to check every single character of the password. So the data type of our password is string, and as we know, a string is a combination of multiple characters, and we want these functions that we used earlier, such as is uppercase, is lowercase, is digit, is special, to be checked on every single character. Hence, we'll be using a for loop to basically check these conditions on every single character of our password. We'll also be using if conditions to basically uh, check these conditions. So if if there is any uppercase letter present in our password, so this value of has upper will change from false to true. Similarly, if there is any lowercase letter in the password, this value of has lower will change from false to true. Similarly, if there is any digit from 0 to 9, again the value of has will change from false to true. Also, if there is any special character, again this value will change from false to true. Now to calculate the score of the score, we'll be defining a new variable strength score of data type int and we'll initialize it to 0. Now we'll be checking conditions such as if the length is greater than equal to 8, this strength score will change from 0 to 1. If there is any uppercase letter present, this score will change from 1 to 2. If there is any lowercase letter, the score will change from 2 to 3. If there is a numerical digit from 0 to 9, the score will change from 3 to 4. If there is a special character, the score will change to 4 to 5. And finally, based on these scores, will be given a rating from very strong to very weak. For example, if the score is 5, the rating will be very strong. If the score is 4, the rating will be strong. If the score is 3, the rating will be moderate. If the score is 2, the rating is weak. And if the score is either 0 or 1, the rating will be very good. So to summarize, this function basically assigns points for each satisfied condition. The conditions are as follows: length, uppercase, lowercase, digit, and special character. The use of if else makes this code more efficient and concise, and also the use of the for loop also saves time because so that we don't have to do this process again and again. Now I'll be defining a new function Provide print suggestion, basically print suggestion and give us a feedback. So again, we'll be using the variables that we define in main function, such as password, as upper, as split, and as special. So basically, what this function does is it prints personalized feedback. For example, if the password length is not greater than or equal to 8, it will give a feedback to the user to increase password length. If it does not have an uppercase letter, it will give the user feedback to add uppercase letter. This exclamation mark is basically denoting not. So basically, if it does not have a lowercase letter, it will give a feedback of add lowercase letter. If it does not have a digit, it will give feedback of add numeric digit. If it does not have a special character, it will give feedback of add special character. This basically helps us to guide user to make their password stronger. Now we'll finally recall these state functions in our main function. So basically again we will define a new variable string of data type string and we'll be using a function check password string and we'll be applying on these variables that we declared earlier. And finally we'll be using cout to output the password string. Now we'll also give suggestions to the users. Hence, we'll be using the function print suggestions and we'll be again using the variables that we declared earlier. So basically, we'll be integrating all these sub-functions and finally calling the function check password strength to calculate the overall strength of the password and also calling the print suggestion to give a real-time feedback and suggestions to improve the strength of the password. And now finally, we'll be using return zero to terminate the program. Now we'll be jumping into a VS Code to check how the code works. So I have validator ID, which is VS Code. To be summarized, first we included the library IOStream and string. We called functions is uppercase, is lowercase, is special to check for the conditions required to be a strong password. We also call the function check password strength to basically give us a score based on the conditions met and give us a rating. We call the function print suggestions to give us a real-time feedback and suggestions to improve the strength of our password. Finally, we call all these functions in our main function. Now I will be running a live demo of this code. So as you can see here, it is saying me to enter my password. For example, if I typed my name, it is giving me very weak because first of all, the length of our password is too short. Then it does not have any uppercase letter. It does not have any numeric digits, and it also does not have any special character. I will be running this code again. For example, I type this. Now it is showing me weak because I have made the length greater than 8, but still I have not added uppercase letters, numeric digits, special characters. So again, we will run this code. For example, I write this. So it is showing moderate because again I have used numeric digits and special characters. So if I write this, it is showing strong and still not very strong because there are still a special character missing. Again, we'll run this. And you can see finally it is showing very strong because I have met all the conditions necessary for a password to be strong. Now to again improve the function of the password strength analyzer more, we can also include the regress library. Basically, it is a library used to check the presence or absence of patterns. For example, if I type here digits repeated and I add here some random words, now so it will check if these are repeated or not. So if these are repeated, then the score will be reduced from, for example, 4 to 3. It will also look for sequential like A, B, C, D, 1, 2, 3, 4, Q, W, R, T, etc. Again, if the sequential are present, then it will reduce the score by 2. Now, to finally conclude, we can say that our code demonstrated modular programming, basically program done by dividing the code into various modules of software. It also shows different use of functions and condition checks like if else. It also used for loops to check through the conditions for each character of the password. It also showed a real-world use in login systems because we know that strong passwords project our digital identity. This analyzer also educates users on better security habits. So finally, it is a C++ program with a real-world relevance.